Okay, so to do this hypothesis test here, the first thing we need to do is set up our distribution and recognise that it is a binomial distribution. In year 13, you'll also see normal distribution. So what I'm looking for is discrete, because the patient is either cured or not cured. So that's how I know it's a binomial distribution, and because there's a limit to the amount of patients. So first, I will start by saying x is distributed binomially 20, p. We leave the p blank because that's what we're testing. And I will say where x is the number of cured patients. It's important to always define what your success is, because in some cases you'll be given other information in the question, so you really need to be clear. The success I'm saying is that they are cured, not that they aren't cured. Again, it's obvious, but we just need to be clear. So then I will say H null. My base hypothesis is the probability I'm given in the question, which in this case is 2 over 5. So P equals 2 over 5. You can just convert that to 0.4 if you want, but equally calculators can handle fractions. H1, my alternate hypothesis, the doctor claims his drug is better, so we're saying that under this drug it is an improvement, so greater than 2 over 5. Now, to do the actual test, I will say let x be distributed binomially 20 and 2/5. So now I'm assuming H null, and I am going to test the probability that x and is going to be some variation of 11, because we've got the 11. Now, this test here is always this or more extreme. So when I'm looking at my distribution, I've got like this is going to be the 20 end, this is going to be the 0 end. 11 is going to be here somewhere, because it's closer to this end than it is to that end. So I'm looking for greater than or equal to 11. Okay? So from here then, we just need to use our binomial probability to work this out. We know that this will be 1 minus the probability x is less than or equal to. I'm just going to very quickly draw my number line. So 10, 11, 12. I want these, so I need to minus 10 and below, so less than 10. Remembering your calculator can only do less than or equal to 10. Cross that out because I don't want that in my workings. I will then get my calculator out and work out that probability. So then, having put it in my calculator, I will do 1 minus 0.8724787542. Always write this calculation down, because there's a little bit in the mark scheme that's looking to see you with that number, and you don't want to lose a mark because the examiner misses where you've done that. Then just work that out. So this will be then 0.1275212.458, which is, rounding it a little bit, 12.8%. Having worked out that it's 12.8%, then I will conclude 12.8% is greater than 5%, the significance level of the test. Therefore, insufficient evidence to reject H null. His drug may not be more effective. So nice and easy there. What we're doing is we compare our probability to the minimum acceptable probability we've said, which is what the significance level is. Then we write the standard sentence, insufficient evidence to reject H null, and then explain what that means in context. So in this context, the doctor's trying to say, my drug's better, but our test has just proved that, that in normal probability, it's likely enough that 11 out of 20 of them still got cured. So it's not actually necessarily more